Good afternoon, everybody. First of all, I'd like to thank Laura Mancini for inviting me in this prestigious symposium. I'm a researcher of INEA, the National Institute of Agricultural Economics. We are involved in research and technical assistance activity to ministry, regions, and local institutions concerning natural resource management, mainly water, so irrigation and energy. I've heard a lot of interesting presentation in these days concerning water quality issues. How presentation is more focused on quantitative management of water resources. Just a short layout of the presentation. We want to identify the potential contribution of irrigation management in the achievement of climate change mitigation goals. We made a brief introduction on the political framework and then focus on the two fields that represent the core business of our institute, meaning research, technical research activity concerning also innovative approach and solutions, and technical assistance activity to, as I said, the Ministry of Agriculture and regions and local institutions. So we will focus on the methodologies to obtain water saving in irrigation management, and then to enhance what could be the potential contribution from the public point of management of water resource to the reduction of greenhouse gas emission, and thus climate change mitigation policies. And then we'll present some results of our activity. The climate change political framework starts from 1992 with the Conference of Rio, where was established the UNFCCC, the United Nations Framework Convention on Climate Change. For the first time, to the climate was recognized as a common resource. This is a voluntary agreement convention, and it's expressed by protocol, the famous Kyoto Protocol, where was established the objective of greenhouse gas reduction of 5.2% in the first period, with the sub-objective for Italy of 6.5%. These are linked with the agricultural policy, where we have to face with the challenges regarding food security, regarding demographic growth, and regarding the increasing of energy needed, facing with the scarcity of natural resources. So agriculture is called to contribute to the greenhouse gas mitigation and to increase the resilience of agricultural systems. The Europe decided to have a leadership position since 2010, where was instituted the DG Climate, which promote the European climate change plans. In this framework, the agricultural climate change potential for mitigation was mainly focused on the renewable energy production from the sector, and of the potential of CO2 capturing and storaging. The framework evolves with the Europe 2020 strategy, with the Climate Energy PAC 2020, meaning 20% of renewable energy production, a reduction of 20% of greenhouse gas emission, and a reduction of 20% of the consumption of energy through the increasing of the level of energy efficiency. In the midterm, these objectives have been developed in the Europe 2030 goals, with a fixed goal of greenhouse gas reduction of 40% and 27% of production of renewable energy. In the long term, we find the roadmap 2050, where the objective, as you can see, pass to 80 and 95%, with about 50% for the agriculture. What's the linkage between climate policy and Water Framework Directive? I said we're not talking about quality issues. We tried in a previous study to address the limitation of the water quality for agricultural production. We found some difficulties due to the perhaps incomplete framework of the law. But we know that the quantitative and economic topics concerning water management in agriculture are essential to optimize the water management, because agriculture, I said, it has an estimated consumption. I prefer to talk about use, not consumption of agriculture, but in some cases it can reach the 80% in southern Italy region. So we have a need to save water in agriculture. We have a need to use less water in agriculture to increase availability for other uses under economic evaluation, and to provide more water available for other uses, and considering that less water used in the fields means also less energy consumption for the pumping of the water in the irrigation schemes, and thus CO2 lower emissions. So we defined two different roads. From one side, we try to develop innovative approach to reduce the energy consumption for the crop. From the other side, we wanted to estimate the potential contribution of the irrigation management in irrigation consortia to the objective of decreasing the CO2 emissions. Saving water from irrigation management means essentially to define what is called the crop water requirement, or ETC, evapotranspiration. Crop water requirement is the total water needed for evapotranspiration, ETC, for a given crop in a specific climate condition. This is the definition of the International Community of Irrigation and Drainage in 2000. The technical approach to evaluate the crop water requirement for a given culture is using the water balance and using the remote sensing approach. Water balance represents the actual evapotranspiration value that is resulting from the actual condition of water availability in the soil. The remote sensing approach can calculate the potential evapotranspiration, namely the maximum volume for a crop under standard conditions, meaning excellent agronomic and water management condition. And this is defined from FAO methodology. So this graphic is important to clear what is irrigation and when it is needed. We say that water balance explores the interactive relationship between energy and moisture in a fixed place, and it is based on the water deficit in the soil, delivered by modeling moisture demand from one side and supply, meaning precipitation and soil moisture storage. In the graphic, you can see that where the water in the soil is sufficiently to guarantee the need of the crop of water, we don't need any irrigation intervention. But where we find between the green light, under the green light, it means the soil and the condition and the atmospheric condition are not able to guarantee the water needed from the crop, and so that's why that's the situation when irrigation occurs. The remote sensing approach is based on FAO methodology, and we can find two different way of calculation, a crop coefficient approach and a direct ATC calculation. A crop coefficient approach is a relation between a crop coefficient of a data crop, fixed agronomic value, and a tau, which is a reference crop evapotranspiration value, which is considered as hypothetical for that kind of crop. The remote sensing approach occurs when establish a linear relationship between the normalized difference vegetation index that is derived from the processing of the interpretation of the satellite images. Concerning direct ATC calculation, which is an approach more detailed because we can see that are needed climatic data and vegetable variables, the analytical approach of the interpretation of satellite images is useful to evaluate the vegetation variables R, Li, and HC directly for the interpretation of this image. So we can see that as an evolution of the FAO methodology, as an implementation of the FAO methodology, the satellite images can provide more detailed information about the crop process of growing with the intersection of climatic data that can be useful to define what is called the real crop water requirement of the culture in that fixed point. Concerning the potential of irrigation consortia to promote the plural use of water resources, we have conducted a survey from the Agensud, which is a kind of district of the Italian Ministry of Agriculture in charge of financing water infrastructuring in southern regions Italy. They've been entrusted of financing the hydroelectric plants in all the consortia, so not only south but also north of Italy, and they thus conducted a survey to define what could be the potential of the sector. They recognize about 211 plants, 155 in the south and 56 in the north. These are just a couple of slides to fix the number we have found. The total power of the plants was about 122 megawatt globally. There has been, you see two different graphics because from the project presented in the survey, we have done an elaboration concerning the economic sustainability of that project because not all were financially sustainable. The annual potential capacity is about 358 gigawatt per hour, with the average of 1.9 for the center-south and 1 for the center-north. And what is the interesting aspect of this survey, that also contributing to reduce the climate change impacts because of the increasing of the production of renewable energy. We have potential revenues from the consortia because of the national incentivation systems. Just a couple of minutes. Okay. That's what we mean with the economic impact of this production of hydropower energy from the consortia. We can say just the case of Abruzzo region. We found that the revenues from the the production of renewable energy can cover the whole cost of energy supplying for the consortia, also generating revenues. These revenues can be turned into lower tariff paid by agriculture, by farmers. So a final discussion presenting a couple of elements of a project we have conducted in the 7th framework program. In 6 pilot farms, we have tested the methodology of interpretation of satellite images to reduce the crop water requirement. We have achieved a saving of 63,000 cubic meter of water, which, adopting the coefficient of conversion of energy needed to provide 1 cubic meter per water, is about 2,500 kilowatt per hour. It can be translated in CO2 reduction. Also, the other side of the slide, the plural uses, we have found economic and environmental benefits of a different scale, because the whole consortia potential could cover about 3,060 tons of CO2 avoided. I stop here. Thank you very much.
Thank you.